Hey everyone, welcome. Welcome to today's live stream. This is an impromptu live stream where I'm going to be reacting to a CESMII webinar, the Smart Manufacturing Interoperability, and I had to delete the word because the title was too long, but it's the Interoperability, what did it say here? And Harmonization panel, Interoperability and Harmonization panel. All right, I got that one. But real quick, I do want to share, let me share the screen here because I do want to give a shout out to JS. JS from a community Discord server was the guy who suggested I do this. If you guys want to suggest future video ideas, go ahead and go to the video ideas here. Here's a video reaction to the CESMII webinar, so that's what I'm going to do. There will be a link below if you guys want to register and give your information to CESMII. We actually have someone from CESMII in our Discord, Roy Koch. No, actually, I think he's not with CESMII anymore. But pretty big fans of CESMII, like what they're doing. They talk about the unified namespace a lot. So someone said, hey, you should react to this. So that's what I'm gonna do. Real quick, a couple updates. So I did cave in. I did put my deposit on my Model Y performance. So I'm going to be getting that next year. Really looking forward to that. We talk about Tesla all the time. So I figured, hey, might as well put my money where my mouth is and invest in a Tesla. So I'm going to be turning it into an asset as opposed to a liability. And I'm going to be talking a little bit more about that on my channel. Second update, you notice my background looks a little bit different, like the kitchen. And I got like these shelves. So it's becoming slightly less of a bachelor pad. The reason being is my girlfriend Anna did move in. So it's really exciting. For you guys that don't know, I moved to Salt Lake City earlier this year, like in July. I met a Ukrainian girl. We really hit it off. And after about 4 months, decided to move in together. So that's been going well. Thank you guys for all the support. Walker Reynolds did do Mastermind this morning. And so that was pretty exciting. We talked about supply chain part 2, talked about OEE, really talked about like quote to delivery and contract manufacturing for virtual insourcing of your manufacturing supply chain. So that was pretty exciting. We're really doing a lot. So it's just really exciting times. And our Discord server is almost at 3,000 members. So if you, there'll be a link down below to join the Discord server. If you scroll down all the way to the left here, you'll notice 2,940 members. That's a lot. So thank you guys for all the support. And in a minute here, once everyone gets in and joins, say hello in the chat, say where you're joining from, or leave a comment down below. This thing is about 2 hours, so we'll see how long it goes. And I'm going to be really nice to CESMII. Not because I have to, but because, they are trying to do the right thing, right? They are government funded, but they are trying to improve interoperability in manufacturing. And that's what we do with the unified namespace. That's what we teach in Mastermind. That's what we teach in mentorship. That's what all of our video content is about. Sponsor for this month is HiveMQ, but I'm not really going to put HiveMQ said, hey, if you guys do any reaction videos like what you did with Rick Belota, the shootout, they didn't really want their name associated with stuff like that. So this video is not sponsored by HiveMQ, but we still love HiveMQ. The next video will be sponsored by HiveMQ the whole month of November, with the exception of this video. So without any further ado, let's go ahead and let me share my screen. All right, first we got to take a breath in, breath out. I always get a little nervous when I do these things. All right, Chrome tab. Go ahead and share audio tab. There we go. Again, you can use the link down below to register if you want, or you can just watch this here. I imagine CESMII would be thankful for us sharing this content on our channel, giving it a wider reach to our audience. So let's begin.
Well, good morning and welcome to day 3, session 1. I think we've got another phenomenal session outlined for you here. I'm particularly excited about the Interoperability and Harmonization panel here. We've got some of the world's leading proponents and practitioners in this space on a great panel with Jonathan Wise, which I think you'll really enjoy. After that, a brief but profound look at enterprise interoperability with Federico Sciamarella from MXD and myself, and we'll wrap up today with what I think is a really powerful look at what AI and scaling AI and machine learning in manufacturing looks like, with 6 of some of the most compelling and accomplished AI machine learning thought leaders and vendors in this space. Our session 2 today begins at 2 o'clock, but for now, enjoy the show.
Well, good morning or good afternoon, wherever you are. My name's Jonathan Wise. I'm our VP of Technology here at CESMII and the Chief Architect for the SM Innovation Platform. Today I have the privilege of hosting a most distinguished panel discussion. If you don't recognize the faces yet, I'm sure as they introduce themselves, the scope of their leadership and their influence that they provide in the space of smart manufacturing will become evident.
Eric.
As the moderator, I don't get to answer my own questions today from a CESMII perspective. So I'd like to open with just a few thoughts. CESMII is not an organization that takes sides or is involved in marketing a particular technology or product, but we're not entirely agnostic either. We do develop opinions on which approaches or ideas seem to have merit, and we try to invest in the emerging ideas that seem like they have a good chance of making a difference. But that doesn't mean we're always right. The development of both science and technology is an iterative process. We posit a theory, we develop an experiment to test that theory, we gather data, we refine, and we repeat. And whether we're right or wrong, what CESMII is trying to do is accelerate. We want to accelerate the evolution and adoption of SM technology in a way that lifts the burden of this experimentation and iteration off individual manufacturers. In order to do that, we need to be able to share the lessons learned to make sure that we're not each individually repeating mistakes or subjecting each manufacturer to the same kind of painful points in their evolution. The participants here today are people who have been a part of that iterative process, developing smart manufacturing technology for decades. Consider them like guides on your journey. They can help you avoid pitfalls, and they can help you make your way forward faster. There's a lot of noise out there, a lot of marketing, a lot of folks claiming to know the only right way to Industry 4.0. The reality is everyone's starting from a different place, with different systems, with a different technology foundation that they've got to work from. In our conversation today, our hope is that you hear guidance from these guides, that you're encouraged to start your journey, and that you can avoid some of the common pitfalls along the way. So I'm going to ask each of the panel participants to introduce themselves personally, but also the foundation or organization that they represent and kind of the lens that provides for them on this smart manufacturing problem. Arlen, you're first on my screen, so I'll ask you to go first.
Okay. Hello, everybody. My name's Arlen Nipper, and I am the president and CTO of CESMII Solutions. I've been doing industrial solutions, mainly industrial communications, for 43 years now. About halfway through that career, I was very fortunate to be able to, on a project for Phillips 66, work with Andy Stanford Clark, and I'm one of the co-inventors of MQTT. That was in 1998. As I look back and look to where MQTT has evolved to today, it's been incredible. But one of the things I point out is that it was invented for operational solutions, and that's where we're really trying to focus as CESMII to reapply MQTT solutions to the manufacturing space, and then subsequently CESMII, we're one of the founding members of the Sparkplug Working Group that's trying to give some structure and definition to how best to use MQTT in industrial solutions.
Eric?
Hi, my name is Eric Barnstead. I'm the Chief Architect for Standards and Consortia in the Azure IoT team. Been in the manufacturing and automotive space throughout my career, and I represent Microsoft in various different organizations, including CESMII, the Platform Industry 4.0, the OPC Foundation, and a few other smaller organizations. So in my role, I'm really helping product teams implement open standards in Microsoft products. I'm contributing to open standards, and I'm a big believer in openness and open source technology.
So this is, for anyone who doesn't know, Eric Barnstead is a huge OPC guy, OPC UA. He's actually been, we've done a couple of reaction videos. After this video, I'll put a card right here that shows us reacting to one of his posts, but breaking it down. He's not a huge fan of MQTT, especially not a huge fan of Sparkplug. Says things like Sparkplug creates vendor lock. There's some misinformation that has been spread. So it's actually pretty exciting. Probably a little bit uncomfortable for these guys. They're almost like in a boxing ring, right? Stefan Hopp, OPC Foundation, as you guys know, not a huge fan of MQTT. I don't know if he's ever even said the word, but this is actually pretty exciting that these people are all in the same room together. So just to provide a little bit of context.
Thanks. Andreas?
Yeah, hello, everybody. My name is Andreas Fatt. I'm with the VDMA, Mechanical Engineering Industry Association, where we have more than 3,300 member companies, and we are trying to develop together with our partners and companies the global production language based on OPC-UA. And I have the great luck that I am leading these activities, and we decided to do OPC-UA and the companion specifications because the OPC-UA technology directly has the power to fulfill our requirements from the mechanical engineering industry.
Stefan?
Yeah, first of all, thanks for having me here on this call. My name is Stefan Hoppe. I'm the president of the OPC Foundation. I guess I am that a little bit because I was a person who first, I didn't develop and designed OPC-UA as a standard, but I was offering the world's first product. At that time in my role being a...
Okay, I didn't know Stefan Hopp had such a strong German accent. I knew he was like a Beckhoff guy, so I probably could have put two and two together. I think this is the first time I've actually seen him on video. He does a lot of like blog stuff, but this is pretty exciting.
Product manager at Beckhoff, where I started 26 years ago. Since that, as an electrical engineer, I was always dealing with automation, machines, field bus, controllers, but also connecting them vertical to IT and databases. The OPC Foundation is, I think, the world gravity center for industrial interoperability. This is our mission. We have over 840 member companies across all the world, from the OT world, but also the IT companies. So Microsoft being here part is one of the members, but I also like to member Google Cloud or AWS, SAP and other big brands. So together we try to really provide industrial interoperability, really scaling from the field up to the cloud and back. That's our mission, and this is why I truly believe and strongly believe on collaboration. And by the way, Arlen, it's a pleasure for me to meet you here in person, because obviously we are also using relevant standards like MQTT, which is part of our OPC-UA development, and it's integrated, but I guess we talk about that later.
All right, and Russ.
Hi, I'm Russ Waddell. I'm the Managing Director for the MT Connect Institute, which is the standards development organization for the MT Connect spec. That's primarily a semantic information model for discrete manufacturing equipment.
Thanks. So there's some overlap between each of your organizations as far as kind of technology choice or emphasis. There's points where you work together, but there's also different reasons each of you is evolved. OPC Classic has been and continues to be incredibly important as kind of our legacy common protocol for manufacturing. MQTT was created as a very lightweight pub-sub protocol, and MT Connect that Russ represents originally specified both a protocol and that semantic information model. Russ, let's start with you. I'd like to ask you to describe the difference between those two ideas, a protocol and a semantic information model.
So at its most simple, the protocol is how you pass data from place to place or system to system, whereas the model is what's actually in that data being passed. So we're concerned with what are the different parts of a piece of factory equipment, how do they relate to each other, how do they stack up contextually, and how would you be able to pick that apart if you just had that information someplace far away from the factory floor? How would an analyst or another user or even an automated system be able to understand this is a machine, it's different from that machine, it has these pieces? That's the information model piece. The protocol is how do you carry that safely and securely from place to place to place, from user to user?
So you started with both. Relatively recently, at least in manufacturing terms, MT-Connect has been published as an OPC UA companion specification. What does that mean, and what does that mean for the future of MT-Connect?
So the idea historically is we want to be focused on what we know and what we're good at. So MT-Connect is organized by getting volunteers from industry, whether they're building equipment or using that equipment or integrating that equipment and building software solutions. Those are sort of the stakeholders in the MT-Connect universe. And what they carry is industry-specific knowledge about how words ought to be defined and what we ought to call different things. What they don't necessarily carry with them is what the best way to pass data from place to place is. So OPC UA offered sort of a framework for how you would do that and carry definitions that require industry volunteers in the MT-Connect space and take that information and handle it professionally, appropriately, and up to the requirements of industrial users without us having to basically invent a protocol. Now, in 2008, there was not universal acceptance of any one protocol or another, so MT-Connect has a protocol built in. But conceptually, we're protocol agnostic, and future-looking, we're interested in supporting passing information over whatever model the user is looking for and whatever an integrator might be looking for as far as how they want to carry information.
Okay. So, Stefan, if MT-Connect can be implemented over OPC UA through this companion specification that they've published, what is OPC UA? Is it providing a protocol? Is it information modeling language? Is it both?
Yes, it's both, but maybe it's even much more because there are other technology bricks which you need. But first of all, to answer your questions, definitely yes, OPCUA is it's not a protocol, it's a framework. Think about the Lego bricks, and each brick is a technology building block for discovery, initial connection, online, offline configuration of machines, information modeling, as we listened before and heard before, but also for transport on different multiple protocols, not only one protocol. I mentioned MQTT already, but we are also providing, obviously, over TCP, UDP, and other topics. Maybe we talk about that later. Security is mentioned. Security is never, ever ending. We always find better security, more stable, more secure security. This has to be integrated. So overall, it provides the best-in-class data modeling. We believe protocols become less important in the future, but information is more important. But not to forget, we have a lot of services on top of the protocol, which other protocols don't have, for heartbeat, audit functionalities, and so on and so on. And again, I can't tell all of us security, 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 because without security, information and protocols have no value.
Yeah, so follow up on that. We've got all these building blocks. Security is an important one. There is a mechanism for transmitting data, but this other important one that we're talking about is the information model, which is what the MT-Connect team kind of implemented as a companion specification. So if they're each building blocks, how can OPC UA use a different building block for transmitting data like MQTT? How does that work?
Yeah, first again, because we have two partners here. One is MT-Connect, the other one is VDMA, and I guess both will talk more in detail about that. OPC Foundation does not have the domain expertise. We don't know how to model a CNC machine best or a robot or a pump. This is exactly where we trust and work together and cooperate with other associations as a multiplier. But once something is relevant for the market, from an information model point of view, but also from a protocol point of view, then it will be integrated into the OPC framework. We just add another Lego brick, another technology brick. And with integrating that, extending the functionalities, we can grow into another market. That's exactly, for example, how we added MQTT a couple of years ago. I think it was, we started 2015, and in the specification it was early 2018, including prototypes and so on. But we also integrated REST API, but we are not only growing up to the cloud, we are also growing down into the field. For example, we joined the Ethernet APL initiative, allowing to grow OPC from the edge down into the field level, into flow meters and so on, that you have a consistent information model from the device up to the cloud and back on all the layers, right?
So OPC UA kind of gives you this framework into which you can plug different Lego blocks. MQTT is one of those Lego blocks that you worked on. And Arlen, as one of the co-inventors of
All right, so look at Arlen's face.
MQTT, I've got to imagine you've seen it go further than you could have predicted when you were first creating it. Use in OPC UA is one thing, but MQTT also provides a technology used in both Amazon and Microsoft cloud platforms, a wide variety of IoT solutions, and in so many classrooms. You followed that up.
All right, that's not entirely true. The implementation of MQTT is not the same in AWS as it is in Azure, right? So that is not actually true. There's a reason we choose AWS over Azure, because Azure tries to steer you towards the partner solutions. Walker's talked about this all the time. Oh, this is hilarious.
With Sparkplug, what are some of the goals of Sparkplug B as a protocol kind of growing up from MQTT?
Well, Jonathan, you're right. I had no idea that, I would go to college universities and people have their Raspberry Pis and they're running MQTT and Node-RED and their Alexa devices sending MQTT commands. So it's been an incredible journey, just seeing the adoption of it. But the thing that one of the reasons we started CirrusLink was to get back to the foundation of why we invented MQTT and how it was used. And one of the analogies that I use is that the Internet of People exploded from two open technologies. The first one that was around was HTTP. That was your messaging transport. And then somebody came along and said, well, we should define what's inside of that. So, HTML came out and the Internet of People exploded. And I think we're looking at the same thing for the industrial Internet of Things, is that we've got a dominant transport, MQTT, but we needed to define what were in those MQTT messages. And you've heard me say, the great thing about MQTT is you can publish anything you want on any topic. The problem with MQTT is you can publish anything you want on any topic. So with Sparkplug, we literally invented that originally at CirrusLink for our own sanity, just to give us this unified namespace that we can all agree
unified
on.
namespace.
Well, then it migrated, industry started taking it forward. So now it's all been contributed to the Eclipse Software Foundation. That is where the Sparkplug working group is, and that's where we're going to do all the technology conforming test kits out of there as well.
Cool. You used a key word in there, which is the unified namespace, and you started out trying to kind of unify your own use of a namespace. But Sheffield University recently published results of their effort to use Sparkplug B with a namespace they didn't define. They called them common data structures. How did that work? Where did those common data structures come from?
Well, it's interesting. About 3 years ago.
Well, common data structures has nothing to do with unified namespace. Unified namespace is architectural methodology. Common data structures are what the University of Sheffield, which is actually, if you go to the link, thefactoryplus.app.amrc.co.uk, I'll leave a link down below. They did the Factory Plus framework that uses common data structures. So they took, really what they did is they took the robot OPC UA companion spec and made it a robot CDS or common data structure for Sparkplug. If you go to that website, you'll see Arlen Nipper's face on right on the front. So just quick point.
Ricky Coles, who's a professor at Sheffield, called me and said, "Hey, Arlen, can you get on some webinars with my students here in the manufacturing sector?" So I had about 3 webinars with them. We talked about MQTT, we talked about Sparkplug, they asked a lot of questions. And then I didn't hear anything back from them for a long time. And then they sent me an email and said, "Hey, could you review our Factory Plus framework?" And it was incredible because what they did was they took a OPC-UA companion spec of a model and they implemented that in the Sparkplug template. So literally, they are now publishing OPC-UA models over Sparkplug. So it's a very interesting project, and I give all the students at Sheffield kudos for
look at Stephen Hopp's face. He's so pissed. He looks like
really implementing that and getting it out there.
Yeah, absolutely. Kudos to them. There's another organization that should get some kudos as well. So they use these common information models that are available as published OPC-UA companion specifications, and that allowed them to have a semantically and structurally reliable information system that was using Sparkplug B as the protocol, as the transport. So that's pretty interesting, but what's even more interesting is where those companion specifications or common information models came from. Andreas, could you tell us a bit more about how VDMA working teams build these information models?
Yeah, of course. This was in my introduction, the global production language. This is where we have really a lot of groups and a lot of companies coming together and developing that. And the important thing is that everybody can build an OPC-UA information model. The important thing is really that this group has to be out of the industry, out of the customers. So the mass of the industry have to be into the group and makes it really an information model, a specification that will be adopted in the market. So really important for us that we are working this as a VDMA, as a leading institution for that, and we have more than 30 working groups, and we got more than 600 companies involved. And as I said, it's all the stakeholders, from the machine builders to the cloud vendor to the manufacturer to everybody who can be somehow using an OPC-UA companion specification. And we are doing that together with the OPC Foundation, to even more guarantee a global cooperation and adoption of the specifications. And this is all based on OPC-UA and IEC standard, which fulfills the requirements of the mechanical engineering. And this also builds trust in the technology. And for example, we have a group from the machine vision. They did a specification. And this joint working group with OPC Foundation was also driven by the so-called G3 association, and this is 5 global standardization initiatives for the machine vision. And there was the AIA from US, there was the JIA from Japan, we had the MVR from Spain, we had the VDMA from Germany, and we had the MVU from China. And 60 companies were involved, and more than 100 participants really sit together and discussed about what are the most important information that have to be standardized in an OPC-UA companion specification to be part of this global production language.
So if I'm one of those stakeholders and I want to participate, or maybe I don't have time to be a part of a working group, but I want to review the output, how can I get involved?
So at first, I would say everybody can be involved because we have really the goal to involve the important stakeholders and also the industry worldwide. And for example, the global mining industry is doing this together with Canada, with Russia, with Australia, and the VDMA and also OPC Foundation. We have processes that allows everybody around the world to be on the one hand part of the group, but even more maybe important that you are not part of a group. You can do a review, because we are doing always a release candidate, and this release candidate is published to everybody. Everybody can read it, everybody can give out their comments, their ideas. Maybe they can also tell us what they don't like or what they are missing. And this is really where we're trying to get the whole world, everybody involved, and everybody who is interested in the topic can somehow give us the needs and the ideas and the wishes. And maybe one thing which is really important, that we as a VDMA, we are not owning the specification groups, or we are not owning the companion specifications. We really believe that the global production language is something which has to be totally open through the public and open source, and this is why we are only hosting the specification working groups together with OPC Foundation. And this is also why you can find all the specifications free of charge in the internet. And if you especially have the idea and want to participate in one of the groups, check the homepage of the VDMA or OPC Foundation if there is a group already existing in your field, and give us a mail. Or if it's not existent and you're planning to do something, please get in contact with us, and we are trying to bring these ideas and the specification work to the next level, to a global level, to the global production language.
It sounds very much like the collaborative process that sort of gave birth to the internet. There's open RFCs that anybody could read. It's not pay to play. These companion specifications are available for anybody to download, to comment on, and to implement. Eric, I think that tees you up nicely. As someone who wears different hats, you work for Microsoft on the internet, on the cloud platform, but you also participate in both the OPC Foundation and the Industry 4.0 effort in Europe. As you look across all of these groups that you're involved in, is it important to have common structure and a common semantic, a common language for manufacturing data? And if it is, why is that important? What does it allow?
Well, it's absolutely critical. I mean, interoperability through these common data structures is key to doing anything on the shop floor or, in fact, in the cloud. I mean, Microsoft is in the cloud business, and obviously building interoperability in the cloud is where we're, spending a lot of effort on. But fundamentally, when it comes to interoperability, there's multiple dimensions. I mean, there's the interface, there's the transport, there's the security aspect. Security needs to be interoperable as well. Lots of people forget that. And then, of course, there's the data modeling interoperability. And only when you have all of these things combined, you have technology interoperability. And then on top of that, in terms of what the data model actually entails, how it is structured, that's where the semantic interoperability comes in. And this is exactly what the VDMA has been driving using OPC UA. So when you have that semantic interoperability, you can do cloud analytics automatically because you already know the structure of the data that will come to a cloud analytics software package. So you can build that cloud analytics software package before you start connecting the first machine on the shop floor. So you're decoupling those two processes, you're gaining speed, you're gaining scale, and you can, really focus on getting your analytics up and running quickly, because that's where the value add is. I mean, a lot of people spend a lot of time just with connectivity problems and resolving connectivity issues and translating data from one format to another. My advice is to use an open standard. It has to be a standard. It has to be something that doesn't belong to anybody, something that's in the public domain. And then, you don't get locked into these, proprietary ecosystems, because, at least Microsoft customers tell us loud and clear that they don't want to be locked into proprietary ecosystems, but they want Microsoft to support open international standards.
Like Sparkplug.
And this is why Microsoft has committed to OP.
So you'd be happy to support Sparkplug then, Eric? Let me know in the comments.
OPC back in 2015, when we first showed up at Hannover Messe with our OPC integration, both in Windows and the Azure cloud. And more recently, we were also joined by Amazon and Google in the OPC Foundation in various different working groups to do with cloud technology, like, for example, OPC PubSub, which is also leveraging MQTT and defines a data model and automatic mapping from an OPC UA information model to a cloud format that all the cloud databases can readily understand. So you don't have to translate the data again in the cloud, which costs time and money.
So in this whole big space, in that framework on which we have to build, and I agree with kind of the assertion that the analytics are where the value is, not on the connectivity. Does it matter if I settle on a common protocol and replace all the infrastructure so that I'm speaking the same wire protocol in my equipment, or is the focus of the problem really elsewhere?
So really, I mean, like some of the other folks on this call have already highlighted, the transport at the end of the day is less relevant, right? I mean, transport gets your data from A to B. Transport protocols come and go. Usually, quite frankly, you have to deal with whatever transport the underlying system support, right? Usually you can't pick, right? But again, these systems tend to...
Well, that's not entirely true, Eric. You can real easily talk to your vendor, get them to support MQTT, get them to support Sparkplug B. We got Zachary Stank in here from Phoenix Contact. They implemented Sparkplug B. So you can choose what the underlying protocol is.
Evolve and new transports become available, maybe something more efficient, and you just replace transport and you focus on the data modeling. That's where the money is. That's where you're spending all your energy, and it's important that the data model stays interoperable so that your data format doesn't change. I mean, you're sending gigabytes of data into these databases and cloud systems. You want the data to be portable. You want the data to be something that you can keep for many, many years. So, to give you an analogy, right? If I come to visit you, you don't care if I use my bike or a car or public transport, as long as I get there, right? And it's quite similar with the protocol.
Yeah, right.
Well, that is unless there's like a train, you come by train and I got to go pick you up because the train station's 2 hours away. Then I might care, right? We want it to go straight to our door, right? Edge driven.
And so I care about what's being delivered by that mode of transportation, so that hopefully we get a visit here. Obviously, a good mode of transportation makes things easier. I care about the content of the message that's being delivered, and can I understand it, and can I unpack it, and can I turn it into value? And what we're kind of converging on here is that if I have a common language for manufacturing or a common information model that defines that structure and semantic, then the transport is less important. So I'm going to ask you one more question, Eric, and I'm going to play a little dumb because you and I both participate in a working team, but I'll pretend for a minute as a questioner I know nothing about it. It seems like if we all agree that common information models enable interoperability, the next logical question is, where do I go to find these information models? Is there some kind of searchable repository I can go to so I can look for what's already been published and adopt that instead of creating my own?
Absolutely, Jonathan. So, I mean, CESMII and the OPC Foundation is collaborating in a joint working group on what we call the UA Cloud Library. It's like a database hosted in the cloud, platform agnostic, that contains OPC information models. And that's important because, like you mentioned, you don't want to start from scratch every time you model a new machine or a new asset, whatever it may be, but you want to leverage what's already there. Similarly, when you're doing cloud analytics, part of your telemetry is your telemetry is only part of the information model, right? It's not the entire thing. So how do you get access to the entire information model? Do you send that at regular intervals? Do you send it in a separate channel? Wouldn't it be much better if it was already available in the cloud and you could just access it from there? And that saves bandwidth, that saves hassle and integration effort. And that's why we decided to make these OPC information models available in the cloud, and of course also the already existing information models from the VDMA and the MT Connect companion spec will be made available in that OPC cloud library.
Yeah, that's perfect. And I think that kind of brings us back around. Russ, I started with you talking about MT Connect. It's fairly well adopted here. It is structurally and semantically reliable information model that is independent of the protocol. But we have to acknowledge that there's some overlap and some semantic differences with kind of related efforts in some of the VDMA companion specifications. And that's kind of a result of parallel evolution, multiple groups trying to solve the same problems and arriving at similar solutions with maybe some terminology differences or data member differences that have to be harmonized. So how do we solve this problem? If we agree that common information models are going to give us this common language, if we agree that the protocol is less important than this common language, how do we move towards harmonization? How do members of the different groups or people with kind of different technology legacy, how do we draw closer together? And I'll put both Russ and Andreas on the spot here.
Also, a quick note, MT Connect I have used before. I used it when developing an OEE application for CNC machines, like Morosiki and Honor, these giant, this was like a 12-foot diameter CNC machine for like titanium rings for like aerospace. MT Connect worked. It worked solid. I got the information out. I used the MT Connect driver on OPC UA, on the Kepware OPC server, right? Kep server EX. That worked fine. So just a quick side note, it's pretty solid.
Well, from my perspective, it's mostly tools. So on the protocol side of things, you can describe a protocol very clearly and cleanly, but if there's not tools that you can deploy that with and can't be tested against, it's kind of pointless to have the spec. So the same thing hasn't quite happened yet on semantic data model side of things. So once you get into the industry-specific definitions, there's no equivalent of I plug these two things together and I'm getting gobbledygook data coming from one side to the other. So we have to get to where the expression of an information model is consumable by a computer, not just a person. And once we have a machine-readable format for a semantic information model, then you build testing tools on top of that, validators, compliance testing, all that kind of stuff comes after. And we're getting really, really close to that. We're not quite there yet, but once that stuff starts to roll out across, say, multiple data models inside the companion specification ecosystem for OPC, that will cause a lot of consolidation as the customer is able to kind of move toward what's working, and it will drive consolidation in kind of the collaboration side of things and the meeting side of things that Andreas talked about extensively. So you got to have the low-level tools, the high-level collaboration and meetings and communication and all that stuff. There's both a business problem and a technical problem, and each one progressing kind of together is where you get to the solution. Andreas, I don't know if you agree with that entirely.
So translation, he said, specification does you no good if there is no machines or software out there that use the specification, right? It's not plug and play like USB. It works in theory, but
so for us, really, MT Connect and the VDMA specifications will have the same goal. It's like a common language for machinery, and maybe the difference is that we as VDMA are directly fully endorsing the OPC-UA technology, and we directly go on OPC-UA. So we have also the test cases for verification in OPC-UA, and MT Connect, well, let's say it's using its own software framework and then goes via MT Connect over OPC-UA to OPC-UA. So for us, it's really important, and we are doing that. And this collaboration with MT Connect is also getting more important and always better from time to time, so that we have our VDMA working groups, for example, for machine tools, together with the MT Connect groups, so that we have a regular exchange between the different information that are in the specifications. But I really believe that we are really on a great journey here, and we are working really closely together on that.
A good example with the library that Eric was talking about is, I haven't met Eric other than this panel. I haven't worked directly with Microsoft except for this panel. I didn't send Eric an information model. I didn't talk to Eric about an information model. The library exists because customers need it. The MT Connect model in OPC exists because that's what both we in MT Connect and the OPC Foundation see as valuable to the customer. And the whole thing kind of happens because the pieces of the system are more mature than they were in 2008 when we wrote MT Connect. So that's what I mean when I say we're getting there. And that sort of example of things just working the way they're supposed to. And I could tell you the same story about Sparkplug and MQTT. And having that stuff just kind of work automatically is good for the customer and basically required for the vendor, or else they're going to get, really beat up in the marketplace.
Stefan, kind of from your leadership position, how does the OPC Foundation think about and move towards harmonization, especially as related efforts maybe converge somewhat around a common modeling language?
Well, first of all, also was what Russ mentioned, you have to certify it at the end as a combination. This is what I just want to add. This is exactly what we are doing for some time already. For example, MDIS and another partner where we did semantic for the oil and gas industry. They have a standard based on OPCUA, and certification is mandatory. So companies checking their undersea drilling robots and whatever other devices and services, because on-site, on-premise failure issues is not allowed. It's too expensive, right? So the OPC Foundation is, I think this is key for the future. Harmonization between information models, because honestly all of these groups have the smartest engineers, the smartest people, and all of them think about we can do the best MES interface, the best power management interface, and so on, and bringing them together on a table and say, hey, we want to achieve something for all of our best. There's no winner, there's no loser. We just have to win here together, cooperate, and bring topics together and harmonize on the information level. I think this is also what the VDMA is spending dramatically high efforts, but also the OPC Foundation is doing that on OPC Foundation level to harmonize information models. It's absolutely key for the future.
Thanks. So we sort of agree the information model is important. We've also kind of allowed that if we have better protocols that maybe have the information model embedded in them, it might be a little bit easier than trying to adapt kind of older, semantically unreliable protocols into a more modern world. But the reality is we're going to have all of these protocols, both the new great ones and the older primitive ones, for a long time. This question is to both Arlen and Stefan, realizing you might have different perspectives. How would you guide manufacturers that probably are looking to retrofit brownfield systems so they can take advantage of some smart manufacturing, or in other cases maybe looking to buy new machines? What should they be looking for in kind of the green fields to make sure that they're well positioned kind of to move forward into Industry 4.0? And then how do we being the folks trying to create information value out of these data sources, how do we manage a multi-protocol universe? How do we do a better job of pushing the information structure definition closer to the source? Stefan, since your mic is hot,
it's got to be
first.
Lightweight if you want it on the edge.
Yeah, I mean, multiple questions. I try to remember all the questions and keep it short. So first of all, our discussion also has shown here that there's not one protocol which will win. And not one protocol is scaling. Fieldbus is not scaling to the cloud. MQTT is not scaling into field for multiple technical reasons. So that's why OPCUA is not a protocol. We are in fact protocol independent. And so for brownfield scenarios, definitely there is a strategy. We made multiple. There's a huge ecosystem with gateways talking to the upper layer OPCUA, including MQTT as transport and so on, and in the lower level using the old Modbus or whatever legacy connection without security what you had before. For greenfield scenarios, starting on from scratch, hey, I don't know any serious PLC vendor, machine vendor who has not OPCUA integrated into the design. into the device. Because then you have end-to-end security till the endpoint. Then you have information modeling from the source directly out of the box, and that's exactly critically important. So this is what you definitely have to take care on. And if you want to play around, why not go to GitHub, everything what the OPC Foundation is delivering on open source, play around with OPCA on a small Raspberry Pi, just takes 15 or 30 minutes, and you can do a connection via OPCA or also MQTT to IT systems. So the information modeling, playing around, downloading companion specs, plus the protocol independent transport is there. You can play around with that easily.
Arlen, it's kind of the same question to you.
Did he just say you use OPCUA when you're playing with a Raspberry Pi? If anyone's ever done that, let me know. MQTT is what you would typically use. That's what that's what at least what I've seen. Like even Wago Kurt, all of his Raspberry Pi demos, MQTT. If you remember at the beginning, Arlen even said, he would have never expected MQTT to be so prolific, where people are playing with it on their Raspberry Pis and sending Alexa commands to it.
Adapt brownfield, adopting the greenfield. What's your guidance? What's the right way forward?
Well, like I said, I've been doing this for 42 years, and for 42 years, that's what we've been trying to do. I think I got out of college in 1978. Modbus came out in 1978. Last survey, to Stefan's point, is the most used protocol today is Modbus. So even though we're having this really nice conversation about nice, clean data models, the problem is that most of this stuff is not connected. And so, yes, it is edge of network computing. It is, having that technology. To Russ's point, it's tools on platforms, not coding on operating systems. So as customers go out, what tools can I get to hook my brownfield equipment and at least get it off the factory floor and get me out of my register value pair? What is Modbus address 40,012 really mean, right, going forward? To Stefan's point, there are PLC manufacturers and edge of network manufacturers and sensor that are building Sparkplug B natively into their equipment as well. So I think it's a combination. I think OPCUA and Sparkplug are going to be around. People are going to use it. They're going to integrate it. They're going to come up with their best solution. But for this overarching is if I can do the same information model, regardless of that technology, then I come out a winner. I've got my information going into Azure Digital Twin or into Amazon's AWS Sitewise service, and I'm creating models that mere human beings can understand.
Eric, does that reflect your understanding as well? Do we need homogeneity at kind of the OT level before we can get to the cloud? Do we need to start ripping and replacing systems, or can we solve this through an abstraction layer and move forward?
I think if I told my customers they have to rip and replace, I won't last 5 minutes. So, quite frankly, brownfield or legacy equipment is going to be with us forever, right? Both to what Stefan and Arlen said. We need to make it easy with the right tools, to Russ's point, to map those legacy equipment to a standard-based open information model. Do that process once. And from then on, use the standardized information model and find an automatic mechanism to also send that information model to cloud analytics systems or on-prem analytics systems. It doesn't have to be necessarily cloud-based, but analytics software is where the value add in Industry 4.0 is in terms of gaining new insights that you couldn't do before. So making that connectivity and data modeling mapping phase as painless as possible, that's what we owe our customers, right? So no one protocol needs to win out. We can't rip and replace. That's just not going to happen. What we need to do is show people the way and how to get their data into a format that they can use going forward, vendor independently, and then create the right tools for the job to make it a seamless experience.
Thanks. And I think that's a good place to kind of wrap up the discussion here. And I'll just briefly climb up on the CESMII soapbox as we wrap up and go to Q&A. I 100% agree with what's been said today. The key point of interoperability is going to be around these information models. If you're a manufacturer with older equipment, you are not blocked by that. We can adapt and implement the necessary kind of bits to connect that to modern information systems. But along the way, we're going to need to kind of normalize or standardize that data. And if you find yourself creating your own information model, if you think that you have the best way to describe a particular machine, stop. There are experts who have been working on that particular problem for up to a decade or more. That's where we need the commonality. That's where we need to adopt some common approaches, some common language. The upcoming cloud library from CESMII and the OPC Foundation will help, but you're also not blocked by that not being ready yet. VDMA companion specifications are published and they're on GitHub. The MT Connect companion specification is published and it's on GitHub. And there are tools for both OPC UA, MQTT, and if you want to evolve towards Sparkplug on GitHub. All of the pieces that we need to build the adaptability are there, and all the pieces that we need to kind of coalesce on a common language are published. We're going to make them easier to get to. We're going to make them easier to adopt, but you're not blocked right now on kind of your smart manufacturing journey by these things. Everything that you need is there, and if you need help kind of finding those steps, that's what CESMII is here for as an organization, not to pick sides in a protocol war, but help you find the steps from where you are to where you want to go. We will switch to Q&A, but just a moment to share my appreciation for this panel. It's really exciting to me that some of you folks haven't met and that we're able to bring you together to meet and kind of share your perspective, but also what you see as being in common, and to hear from each of you that harmonization is important to you. You're not trying to create silos. You're each trying to draw the industry towards being smart and working together. So we'll switch over now and field a few questions from the audience. Thanks, everyone.
Thanks, Zach. I'm interested to see what the Q&A has to offer.
All right. I'll invite my fellow presenters to turn their webcams and mics back on. A lot of questions came in while we were.
I think Russ, the guy from MT Connect, really hit it home for me. That was like my favorite comment. But other than that, I don't know if I really learned. I don't know if I really walked away from this interview smarter, or yeah, we'll see.
Talking, so that's exciting. I give Stefan the first question, and it came in from a couple different folks in a couple different ways. So I'll try to combine them.
It's definitely entertaining for sure.
But as we're talking about helping people connect their brownfields or their existing equipment to more modern protocols so they could support an information model, there's a lot of questions from practitioners or those who would like to be practitioners about what can they expect as far as legacy protocols or prevalent protocols. So Arlen kind of has his perspective that he's seen in the engagements he's been on. Stefan, if people aren't on OPC UA, what are they on from what you're seeing, and what's their roadmap forward?
Well, thank you very, very much. First of all, I have to disagree. Modbus is not the most common used protocol. That's old history. So I nearly know nobody using Modbus. Maybe super old legacy devices, but not in modern PLCs. No, but obviously there's a brownfield scenario, and then well, as always, do you remember when you had old dedicated computers with a PS2 adapter for the mouse, and then USB mouses came up? What did you do? You took these small green adapters, bridging from the small old PS2 adapter to USB. And this is exactly what you do today in modern software architectures. You're integrating an adapter layer, could be with priceless hardware, could be as a virtual machine somewhere, but then you have gateway functionalities from the old world into, for example, OPC-UA, and then what is really critically important, it is not just a protocol converter. Again, we are not
information modeling.
It is not the key point. Key point is standardized information. So the gateways, the solutions, have to be enabled to load standardized information, to expose to the upper world, I'm a robot, or here's my UA for machinery faceplate of the machine. And however you collect the data on the last mile.
Does anyone know of any like OPC-UA faceplates, OPC-UA information model faceplates? Let me know if you've ever used that, like in Ignition or any other HMI.
With unsecured whatever legacy protocol, but to the upper world it should be standardized. Yeah? That's the guidance I can give everybody.
Yeah, there's this great quote. I'll probably mangle it, but any software problem can be solved with another layer of abstraction. So some sort of abstraction layer that goes from whatever you're finding at the legacy level to something more modern is a good way forward.
Honestly, it's just for brownfield devices which you can't.
I think the host just made the case for the unified namespace.
Replace, because you will never ever reach the highest quality of integration with a gateway, because the last mile, the old mile, the proprietary mile, is definitely not supporting service-oriented architecture, where you have a protocol layer which is providing standardized data within one PLC cycle to be exchanged, cycle consistence, data consistence within a cycle, right? And all these features are not integrated with old layers. You don't have security on the last mile. So you have to pay a price for that. But obviously, it's better than having nothing to be quickly connected. Yeah. But if you want to be in the modern world, Industry 4.0, digitalized, well, then you have to spend a little bit more effort and provide modern software architectures and layers into that. Sorry.
No, I think it's a fair comment, but I think I'd add the caveat that in Europe you've been a little more successful in starting with a more fresh greenfield, and here in the U.S. we have a lot of legacy equipment that we have to deal with. You mentioned a companion specification that has a lot of energy in Europe, and I'd like to ask Andreas if you could expand a little bit on OPC-UA for machinery. What is that effort, and how does that apply to this problem space we're talking about?
Yeah, of course. So first, we're doing, I mentioned that domain-specific specifications like for robotics, vision machines, and so on. But of course, they have also in-common information. So for example, an identification of a manufacturer or an identification number, or the status of a machine, or the topic of job management or energy monitoring. This is something which is not specific for the different machines in the shop floor. And exactly those topics which are relevant for the whole machinery industry, for the whole shop floor, for all the machines there, we are defining in the so-called OPC-UA for machinery. And in this OPC-UA for machinery, I mentioned that we already have the topic of status management, so we are releasing that right now. We already have the topic of identification. We are right now on the point of job management and energy monitoring, and we will bring there even more building blocks which are usable for all the machines. And this OPC-UA for machinery serves also as a basis for all the machine domain-specific specifications, like the machine tool specification is directly using the OPC-UA for machinery as a basis, and all companion specifications are doing this, and all upcoming specifications will also do that. So we have really a common layer for all the different machines. And this is, if you think from the perspective of the customer, a really great thing, because the customer don't have to care about the different machines and vendors and machine types, he really gets from all the machines, for example, the same energy information. And this is really a great goal, and we got great feedback, and we have a lot of customers also in those groups. And this is really something what we are driving with the whole community, and we are always also open to get feedback from all over the world and to include the needs from all over the world in our activities.
So related to that, and this might be a little more pointed than in our panel discussion, but Q&A is fair game. Russ, there's overlap there with MT Connect. So what is the plan for harmonization, or a roadmap to having a common information model for machinery, particularly machine tools machinery, where MT Connect is well established here in the US?
I wonder if these are questions coming from the audience, or if these are like questions that they're positing.
So the answer to this is basically composable models, or portable models, or modular models. So they, everybody, each country that has a large manufacturing economy and an interest in standards has a way that they want to do things, and they want to model it their own way, and they want to build it their way, and they want to claim national ownership over that model. That's true in China, that's true in Germany, it's true in the United States, and it's true in Japan. So I don't think that one unified model to rule them all is realistic. I think building models in such a way that they're easily parsable, easily interpretable, and easily understandable, and then portable from system to system is the way that that's going to go. So the way we're approaching that here in the States is formally modeling the MT Connect information model. We're using CESMII. CESMII or UML are kind of the two primary languages for doing that, but that gives you, a normalized, formal, official model, as opposed to hundreds and hundreds of pages of text documents. So that model itself, is being expressed as XMI, which is a XML markup interchange modeling interchange format, and that's consumable by OPC tools. It's consumable by the NC-Link tooling that's in China. That allows you to start with the, whatever the MT Connect model is, and you can translate it back and forth because of the way that we're expressing the model, not because we've reached perfect unity across all definitions. I mean, I would love to say the world has solved this, and at ISO or IEC, we've all agreed that there's one word for asset. But you look at the ISO data dictionary and definitions for asset, there's hundreds of definitions for asset already at ISO. So I think convergence on one term is unlikely. Portability is the way that this will be solved in practical terms.
But sorry, I mean, this is a panel discussion. I particularly like to disagree here because the standards are not driven by countries. I don't see that. Maybe because we at the OPC Foundation feel as a United Nations in the best meaning of automation, but this is not
one standard to rule them all.
Working on. I mean, maybe it's Andreas, where Andreas from VDMA should reply on, I don't know, for example, the machine vision or whatever. Is it a German? Is it a European initiative? Andreas, can you report that?
Yeah, well, I had that in the panel discussion. It's really not like we are doing that on country boundaries. This is something we're doing worldwide. We have companies from the States, we have companies from China, from Japan. What we are really doing in the specifications, and this is really the first and maybe one of the most important steps, we first check if we get the necessary market leaders and, let's say, stakeholders for the domain inside the groups. And this is really where the industry is coming together and is believing that doing a standard for the different domains is worth doing that, and they are really putting high effort in the standardization. And this is why we are really believing that this is nothing which ends in Europe or which is only for I don't know, the States and not for Asia or vice versa. We really believe that by the way we have the critical mass of companies and the stakeholders included in the groups, and doing that together with OPC Foundation, joining together with CESMII in the cloud library, having Microsoft, have the big companies also in the group, the vendors also in the groups. We really believe that this is a way we can do that, and maybe this is a historical thing, and I can understand that a lot of people maybe are looking critically on that, but I think we really have the chance to solve the problem and to get real interoperability by worldwide groups committing on the specific standards.
Andreas, we are engineers. If we engineers are not able to solve it, right, we are not political people, then nobody can solve it. So engineers have to work together independent from any border and boundary and country. Otherwise, it would destroy my complete vision and my passion. Yeah. Okay.
But there's a necessary, unavoidable gap between engineers have worked together worldwide to create the ideal information model, and that information model is found to be present in a manufacturing scenario. And I think maybe in the US we're part of the long tail because we're largely talking about retrofitting. So there's some challenges there. I think there's also some awareness challenges. So for some of the attendees today, this might be the first time they're hearing about VDMA information models.
So let's say
yeah, the OPC Foundation is not a political organization. Not at all, Jeff or JS.
Production language, because as I said, it's not VDMA information models.
If everyone's not speaking it yet, it doesn't matter. There's a human language called Esperanto, which was intended to be a global language, right? But nobody speaks it, so it doesn't matter. We're not there, but we do have a gap that we need to get across. And so there's a couple of questions around that. What do you guys think the challenges are to adoption, and how do we get the industry past that? And I'll just open that one up broadly.
I have an idea, but let's pass it to others first.
Yeah, go ahead, Eric.
So let me just, as one of the folks that are intimately familiar with the challenges of Industry 4.0 scenarios and bringing legacy factories into the modern age. I mean, the main challenge is for sure initially mapping the data, right? And again, you need to pick one data model, right, to do cloud analytics. Otherwise, it doesn't work. You can't send data in 50 different formats to the cloud and expect your data analytics software to cope with it. You need to map the data to a common information model on the edge, so in the factory before you send it to your analytics software. And again, you really want to pick an open standard for that, right? So that's why OPC-UA is taken off in recent years with Industry 4.0 applications. So again, the legacy equipment, mapping the data to that. And actually, I disagree that in Europe, we have the pleasure of dealing mainly with greenfield installations. Not the case. I mean, 99.9% of the projects I'm involved in are brownfield, right? Even in Europe, I think.
Yeah, I don't know where Jonathan got that information. I see a mix of greenfield and brownfield wherever you go.
New factories that are being built in Europe, I mean, it is a handful every year, maybe, right?
Yeah.
So again, you're dealing with the same over the world, and I mean, fundamentally, I also agree that standardizing these information models is an international effort, and it makes our lives harder because we need to have these working group meetings at crazy times to accommodate everyone from Japan, from the US, dialing in at crazy hours. But that's the effort that some people make to harmonize these information models and data models to get to a adopted one. And I also agree that it takes 20 years until you finally have the pleasure of actually working with a machine that supports, and that's why it's so important to have these adapters in between. And I mean, the good news is that these adapters have been around for many years, right? So basically, when some companies jumped onto the SCADA bandwagon and implemented these SCADA software systems, I mean, they already created all these protocol adapters in the SCADA software. And basically what we're doing for Industry 4.0 solutions is just repurposing them to do that, data mapping and data standardization on the edge, right? But the software's been around for a long time, right? What's probably new is that this stuff now works in containers because everybody wants to have an edge-based solution based on Docker containers. So that's new, but the software inside the container is usually 15, 20 years old. So the data modeling is where the big challenge is, in my opinion.
But what is
Jonathan,
the biggest
I would agree
blocker?
with that, Jonathan, in that what we've seen and really the grassroots growth of what we're doing in the Sparkplug working group and the ability to publish a model from the edge, that's really why it took off from that standpoint. So using MQTT, which all of the cloud providers, whether it's Microsoft Azure, AWS, Google, IBM, that is the common denominator of everybody that's adopting MQTT and Sparkplug today, is to be able to publish that model from the edge. I agree.
Yeah, can we drill into that, publish the model from the edge? There's a harmonization effort that I want to highlight around machine identification and the fact that we have at least a dozen ways to do machine identification. And if we could settle on one, we would have some sort of lookup key that would allow us to find what information model we should load for a given machine. So that's one approach. Another approach would be if machines or the servers that represent machines actually present their information model in a standard fashion. So are either of those approaches going to take off? Or are we going to see through the Industry 4.0 efforts some harmonization of an asset nameplate? And then the other approach, are there tools that you guys would recommend that can ensure that the thing that we're building at the edge has an information model present in it? A discoverable information model present in it.
Well, I think what we're seeing now, to your point, Jonathan, and everybody's been talking about the brownfield approach, is that the Factory Plus spec from Sheffield University was a great example of taking an existing OPC-UA specification of a robot model and modeling that at the edge in Sparkplug and then publishing that model out. Now, more and more machine manufacturers are building that capability in. And you're right, in a perfect world, I want to walk into a factory, plug into my infrastructure, subscribe to my factory, and in less than a minute, discover my entire factory. And I think that's the vision that we're all looking for here, whether it's MQTT and Sparkplug or OPC-UA. We're looking for that information model where we can build those dynamically and rapidly with tools on platforms and not coding on operating systems.
Sorry, I have to disagree here. Yeah, I have to disagree. Sorry, because, it's not a vision. It's there. I mean, it looks like we are 10 years in front because it's no longer academic and some students are playing around. Go to Equinor. They have started 2014 and talked to Erich and his colleagues at that time and said, oh, wow, that's great. And I mean, particularly, Alan, I fully agree because I mentioned before, we love MQTT. OPC-UA over MQTT is on the roadmap of AWS, Google, SAP, Microsoft MindSphere, Microsoft Azure, anyway, sure, and IBM. So it is there, and you have industry projects where Equinor is pumping up to 1 million data points into Microsoft Azure. And to not only mention Microsoft here, Eric, sorry, your friends from Google Cloud are connected to Renault automotive company, and they published 300 billion messages, meanwhile, via OPC-UA to Google Cloud. So it's not a vision, it is there, you can just do it. Information models are there, technology is there, certification is there, it's an international IEC standard. So on what are you waiting, by the way? So solutions are there, and honestly, Nathan, the previous question from you was not really answered. What is the blocker? This was your question. And from my point of view, the blocker is mostly around the world, not defined by me. This is the most biggest blocker what I see in the world.
Okay. Okay. What is it? Sorry, I missed it. I talked over you. What's the biggest blocker?
Not invented here syndrome.
Not invented here syndrome. This is the biggest blocker, and it's independent from language, from country, from whatever it is, that always people think, oh, I found something and now I build up a huge ecosystem around this, instead of joining existing organizations, say, hey, by the way, there's one puzzle piece missing, just add it, and we can grow that larger puzzle piece to the best of everybody. This is the biggest blocker around the world.
I wouldn't disagree with that, but I wouldn't attribute it to malice. I think we may be there from a technology perspective in that it's theoretically possible. From a real world manufacturing scenario perspective, I haven't got a single CESMII project where there's already an information model present. Every one of them is building a mapping, including one that just bought brand new machines
that didn't have models.
Had an MT Connect agent in them, but it would have cost extra.
So it could have an MQTT client on it.
It shipped with nothing, right? Like a brand new machine still doesn't have an information model server present in it. And so somebody's left doing a manual mapping. And I don't think it's always because we didn't invent it here. It's maybe just an education issue. Right?
I agree.
It's an education issue.
The success stories I listed are obviously European. Renault is European, Volkswagen is European, BMW and Equinor, they're all European. Yeah. So that's a good point for me. I have to take care to more address international success stories. Good point for me and good feedback.
Well, and I think we should, as we find these success stories, highlight them and use them as education tools to help people get past kind of the mental block or maybe the information block that's standing between them and this brighter vision we're trying to lead people towards.
Well, I could rattle off a few US-based large US manufacturers, success stories, but I think it's not going to help anyone, right? So fundamentally, I agree with Stefan. There's a lot of not invented here syndrome, but not because they're, like you said, they don't like what's there already, but just lack of knowledge of what's available and what can be done with what's available, right? And again, I mean, as you know, I'm working really hard to at least connect the US with the German governments and bring standardization and harmonization to those two manufacturing sites, and a lot more of that needs to happen as well, right? So a lot more of the efforts that we're doing here needs to be internationalized, and looking at some of the most pressing issues around carbon reporting and carbon footprints of produced assets. There's a lot more work that needs to be done there as well, because now that everybody kind of agrees, well, we need to do something to help slow down climate change. The tools and processes aren't in place yet to do that on a global scale, and it's a global problem, right? So it needs a global answer. So I mean, again, we are in the position to help there, and I think we should.
Man, we've got so many great questions coming in, but we're at time, so we're going to gather them. I'll share them with the panelists, and at some point we'll figure out some way to get those responses out. I want to thank everyone again for the participation, just in a really cool panel, a really good discussion today. Thanks, everyone. I think we gotta wrap up.
Thank you.
Thank you.
Thanks.
Bye.
Bye, everybody.
Goodbye. Thank you, Jonathan.
Eric, you should, if you're watching this, or Stefan Hopp, you guys should join our Discord server. There's a lot of people in there, a lot of manufacturers from all over the world. They don't really care that it wasn't invented here or there. I am Zach Scriven with 4.0 Solutions. I do have a background in industrial automation, in manufacturing. I identify as an agnostic solutions architect. That means I don't play favorites with one format or another. I care about what's best for manufacturers. I care what's best for this community. Thanks, JS, for the suggestion to react to this video. I hope you guys found it useful. I really did find it entertaining, at least, and somewhat informative at best. So if you guys did, make sure to hit the like button, get subscribed, turn on bell notifications. Thank you again for watching, and we'll see you guys in the next one. Peace.